All right, so here we are at difference quotients again. Now, I'm saying again because I am pretty sure that this is among the topics that are taught at a course before calculus. Okay, but it's good that we go over this again. Of course, I am not going to go all the way back to ultra basics of what a difference quotient is. But it's worth our time to look again at the difference quotient, because here's the reason. Now, difference quotient, when it's being introduced at any algebra course, college algebra course, or any course before calculus, usually there aren't too many direct applications at that point yet. But surprisingly, when you're actually in a calculus class, then this skill, being able to work on a difference quotient, is extremely vital to your calculus course. And so for that reason, think about the time when you were still in algebra, then it makes sense that this skill that you've learned back then faded away quickly, because as I said, back in calculus, back in a course before calculus, then usually there weren't too many direct and almost like none direct application of difference quotient. And so normally when people get out of an algebra course or a course before calculus, and especially wait for a little bit of time before you enroll into a calculus course, then this skill will fade away quickly. And so that's why my aim here is that in this video lesson, let's give it a second look. And of course, I am not going to go back again, as I said earlier, I'm not going back to ultra basic stuff, but I'm gonna, from whatever you have learned, at least what you have seen from the previous course, here I'm gonna design examples that are a little more advanced and that are good and to prep you for the calculus lesson that's directly apply on the skill right here. Okay, so here we go. So before we get started, well, I will just quickly remind you what a difference quotient is. So I'm going to take this space of my board here to write down a pretty famous and standard definition of what a difference quotient is. So again, we're going to start out with having a function. So let f of x be a function. Okay. So just simply that, we're having a function f of x being defined. And so now, this setup right here, f allow me to write it and switch in color some point here and there. So f of a plus h, and I wrote a in red ink, f of a plus h minus f of a. So f is our given function. So now we're going to set up an expression. So this is so far an expression. It's a function that's evaluated at some expression a plus h minus the function evaluated at a. So of course a here is a given value. Okay, so let me go back to my beginning statement here and add in a line right here. So let f of x be a function, and x equals a be given. Okay, so now this setup, and now divided by h. Okay, simply it's a setup. It's just a setup. And if I was teaching an algebra course, I couldn't do any better than just introducing this as a setup, and any other instructor would do the same thing. This is simply a setup. So it's a setup, and this setup here is called, okay, the setup here, this setup is called the difference quotient. Okay, it's a difference quotient of, so this setup here is based on our function. And so, of course, so it makes sense to regard to that as the difference quotient of our function f of x given previously. And then more specifically, you see how I was writing that value a right here in red ink specifically, because so now I'm going to say it's the difference quotient of f of x at x equals a. So the entire name, I wrote it down in red ink, the difference quotient of f of x at x equals a. What exactly is that? That's what this setup is. Okay, and so as I said right in the beginning of this video, then I am not going to go too far back into the describing what it is, because of course pretty much this is what it is. So let's again get into example 1. And in our first example here, I am going to sort of bring you back some of your review skill of just how we can successfully set up a difference quotient. Okay, and then and from there on we are going to be able to push it further. All right, so now here I'm going to name my example 1 right here for this lecture. How about let's call that let's evaluate. And really, now when I'm saying evaluate, I intend that we just set it up. Okay, that's another way of saying that. Some textbooks, some other instructor might refer to that as set up the difference quotient. Okay, and further simplify. Okay, so evaluate and simplify the difference quotient. Okay, of f of x at given value x equals a. All right, and so now here's our part A of the example. So let's call that f of x equals our function here is 11x minus 4. Okay, and at x equals 3. Okay, and so now let me quickly bring back the other board here. So our function is given to be 11x minus 4 as we have seen, but what the main goal of this problem is to set up the difference quotient. So with the function here, let's have a look closely again. We need to evaluate our function at the expression a plus h. And a in our case here is given to be 3 in this case. Okay, and so again, with the difference quotient as a setup like this, I need everybody to have a closer look. So f of a plus h minus f of a. Okay, and so in that way, here's how I'm setting it, and it actually never hurts at all to just copy down the definition, the setup in the definition that I have pointed out earlier. So here it is. It's f of a is this value, so let's call that f of 3 plus h minus f of 3 over h. That is the setup that we want to point out as a starting point, just to indicate what we're about to do. And it gives anyone doing the problem a good reminder of what the next step should be. And it gives anyone doing the problem a good reminder of what you are doing. Okay, so a lot of good reason of always start out with this starting step right here. Okay, and so now in the next step, of course, now you know that your function is given previously 11x minus 4. Okay, and so what we do here now, that means, and of course at this point that anyone should be viewing this video should be fluent with how to substitute an expression, a value into a function. So I hope I don't have to go too far back into those. So your function here takes input x, so and 11 times x minus 4, but now for f of 3 plus h, the input is going to be 3 plus h substituted in for x. And so in that way, I'm going to look at So f of 3 plus h is going to become 11 times the input 3 plus h. And that's why I have 3 plus h being in parentheses. Minus, okay, and then minus 4. This is f of 3 plus h. And I am going to allow me to a minute to erase my other board. All right, so now I'm going to extend out. Actually, let's still leave that space here. But so I'm going to subtract f of, so now the statement say f of, the setup says f of 3. So that means we're looking at 11 times 3 minus 4. Okay, 11 times 3 minus 4. So I use 2 pairs of parentheses indicating that we have, see, this first group of brackets right here is indicating f of 3 plus h. And this other group right here is the same function repeated, but we're substituting in 3, the given value here. So there we have the difference of the 2 groups. And now we're going to divide by h. That is our difference quotient with the actual 3 plus h and 3 substituted in. Okay? And applicable with our function being applied here. Our function says 11 times the input minus 4. And that's how it produced all of this for us. Okay? And so now, I am going to advance back to my other board to advance with the problem here. So, with my other board already cleaned out. So now in the next step, and I have to now make clear that as far as the setup, this is already the setup. But the problem wants us to go further. So after setting up, we're now going to simplify it. This is a very common work for any time you are working with difference quotient. And again, I'm saying that this kind of example should have already existed in your previous course before calculus. So I'm not going to spend too much time here. Let's now start picking up pace a little bit. Okay, so after the setting up point right here, so now in my numerator, 11 times 3 plus h, a simple distributive law is going to take me into 11 times 3 is 33. And feel free to roll back on the video, to rewind the video anytime you need to look back at the previous step right here. But so now we're looking at 33 plus 3h minus 4. This is after distributing, applying distributive law to distribute out that factor. And I did that a little bit incorrect right here. This is plus supposedly 11h minus 4. That's after distributing 11 as the common factor into each term of my previous step. Minus 4, and now I'm going to subtract. Now the other group right here is simply just 33 minus 4, which is a simple calculation that anyone can take. Okay, and now we're still over h. So you can see that so far throughout all 3 steps so far, from the very starting point to the setting up step that we've had. See, this was the starting point, and then the setting up step, and then now with our current step right here, the h in the denominator pretty much remains the same. And if you now recall any of your examples or any of your experience back in your course before this, prior to this course right here, then and if you have done any of these difference quotients work, the kind of example, it looks exactly the same, where the h stays pretty much permanent in the denominator, unless when we move on to at the very end right here. So let's keep finding out. So what I see now is that it's keep getting simplified, but we got more simplification to get done. So now what further can we do here? 33 minus 4, and then also a 33 minus 4. But you know, in case you don't want to do quick mental math here, this is something that algebra can save you from. So how about I'm going to still keep all these here, but remove parentheses. Okay? There are different options how you can approach. And then subtract. I'm talking about if you don't want to do mental math, to combine these into numbers, which is what I'm lazy to do sometimes as well. Okay, but minus 33 plus 4. Look at the nice thing about this. These are all opposite terms. We can cancel. Those are opposite terms. We can cancel. And it's still over h. But now look at how much it's going to bring it down for us right here. Canceling out all of these, a lot of these opposite terms here. Now we reduce surprisingly down to only 11 times h over h. And 11 times h over h. Now we can even cancel further the common factor h and h in both numerator and denominator. So there we go. And so now after canceling it out, we are now looking at 11. Okay, so that is the answer. And at this point, we can't simplify any further. So that's we have done it. We have reached our goal. Our goal of the problem from the beginning was we want to evaluate or set it up. And after we set it up, we went further to simplify it. And everything we worked on was on the difference quotient. So what we had here was called the difference quotient of f of x. This f of x right here in our case at the given value x equals 3. Okay, and so now before I advance to problem B, so I'm going to create a little bit of a what's so called an FYT, meaning for your trying, so that you can, and anytime we're doing an FYT, it means I am not going to walk through the steps anymore, but you can take your own time, pause the video and work it out on your own, and then I only tell the final answer. Okay, so how about before we get into part B, let's look at an FYT right here. So same instruction of the example. What about our function here is given to be, how about a 5x minus 7, or I'm changing my creativity so quickly, plus 7. 5x plus 7, and at the given point x equals negative 4. Okay, so go ahead and pause the video, okay, set it up, get it simplified, and then I'm going to jump back in, but only show the final answer. All right, so hopefully you are back and having your own work carried out. The final answer for this, and feel free to contact me anytime you need to get clarification of the steps. But here again, this is, since being an FYT here, allow me to hide the steps away, hide the complete step-by-step solution. The final answer after we set up and simplify the different quotients is going to be, what we ended up here is going to be just 5. And that's our final simplified difference quotient after we set it up. But how about I'm going to be a little nicer than how I initially planned to be. The starting setup is going to look as following. The starting setup is going to be f at, we're given x equals negative 4, so minus 4 plus h minus f at negative 4 over h. So that's all I can tell for anyone. And the final answer, you're going to spend your own time working on the steps. And as I said earlier, 5 is the final answer after it's been successfully simplified down. Okay, and so now let's move on to another problem, and where I'm going to again show the steps, and we're going to call that part B of our current example. All right, so here we go. So let's look at part B. How about our function here is, and let me quickly have a look into my prepared problem bank. All right, so the one we have here, how about minus 3x squared minus 11x minus 4. Okay. And actually, I need to make a correction. should be minus 6. And really it shouldn't matter. What we have here is a quadratic function. And now how about given at x equals 5. Okay. All right. So now I'm going to need a lot of space here. So let me erase my board. Okay. So the starting step again. See, I'm looking for the difference quotient of the function. The function f of x is given here. The difference quotient of f of x at the given value x equals a. X equals a is here. A is 5. X equals 5. Okay? And so here's the starting setup, sort of like a general starting point for anyone setting up a difference quotient. F of our a given here is 5. So f of 5 plus h minus f of 5. Okay? And we're dividing that by h. All right. That's how we're setting it up. And this is called the difference quotient of our function. And the next step, I am going to apply our function into this problem. Okay? But have a closer look. See, I want to substitute the idea in the next step. Now I am going to take that expression 5 plus h and substitute that into our function, because that's what it says here. And again, anyone viewing this video shouldn't be unfamiliar with that. You should be familiar with the idea of taking an expression or a number to evaluate, to substitute into a function, to substitute for your variable of the function. Okay? But then for the reason that my function here has 3 terms, having a lot to lay out, so I'm going to completely take the next step in the other board. Okay, so all right, so f of 5 plus h is going to be, now my function was the way how it is, and feel free to roll back to the video, but it says minus 3x squared minus 11x minus 6. So those x's, they are your inputs. So now minus 3, but no longer x. Minus 3 times 5 plus h, because we've substituted 5 plus h for x. So minus 3, and see, you have seen my style far enough throughout previous lectures. Anytime I'm doing a substitution, I use parentheses very carefully. So this pair of parentheses around my 5 plus h is to indicate that I substituted 5 plus h into the role of x. So minus 3 times 5 plus h square, because that's what it is. Minus 3 times input square, and minus 11 times the input, which is now 5 plus h. So again, 5 plus h is in parentheses. So minus 11 times 5 plus h minus 6. This is the other remaining part of your function. So this, all that here is f of 5 plus h. Okay, and so now I'm going to close a pair of parentheses to group that as one group of, or one term, f of 5 plus h. And now the difference quotient setup set, we need to subtract. And now here it goes, f of 5. And so this is how it looks. 3 times input square. Input now is substituted by 5, so minus 3 actually. Minus 3 times 5 all square. Minus 11 times input square. Input, just the inputs. So minus 11 times 5 minus 6. So all that here, ladies and gentlemen, this is f of 5. Okay, so that's why clearly we have 2 groups. This here in that first pair of brackets, f of 5 plus h minus f of 5. Okay, and really, as I'm going along here, anyone, if you already feel strong with your own skill in setting up and simplify the different quotients, you don't have to watch my step-by-step work. You go ahead and do on your own independent pace right here, and or you can even skip this example if you want to and advance to my next example. Everything here is over h. Okay, and so in case your teacher mentioned or didn't mention, but here I can quickly tell you again, the reason this thing is called a difference quotient, because it's a quotient. There's fractions, top and bottom, and each one of these has a difference. That part here has a difference. Okay, and that's why it's called a difference quotient. And it takes a lot more algebra to later on, and later on in the later steps you will get more clarified in later video lectures. But for the denominator here, later on when you grow more mature in math, you will also understand that the denominator came out once as a difference as well. And that's why it's called the difference quotient. Okay, but now here we are. Our difference quotient now successfully set it up with the function f of x properly applied in, and all the inputs are all successfully evaluated. But now we need to go further and simplify. And so now in my next step, 5 plus h all squared. Think of that as 5 plus h times 5 plus h. Okay, I leave this for your own algebra. I have there are tons of resources over the web for you to reveal your skill how to FOIL this out. So I'm only recommending that in case you don't remember any quick trick or anything like that, always think of a square like that as 5 plus h times 5 plus h, two identical factors, and then take your time following it out. It will get you into the correct and proper answer. So after successfully FOILing out 5 plus h all squared becomes 25 plus 10h plus h squared. But that's only the FOILing 5 plus h all squared. All that there is 2 times negative 3, and now minus. Now the next step here, I am going to distribute the negative 11s. So I'm looking at minus 55 minus 11h, okay, and then minus 6. So all that here is my f of 5 plus h, but I'm working it out a little further because now we're on our way to simplify. But before we simplify, we really have to expand everything, right? FOIL everything out, and then eventually start doing all the cancellations thing, and then canceling out common factors and all that. Okay, and so now these in the other groups, minus, now minus 3 times 20. So that takes it minus 75 here, and minus 55, okay, and minus 6. And in case you don't want to do mental math, which is the same case here with me, I don't want to do my mental math right here. So let's save that for the next step, because we have the algebra that can save us a lot of work. Okay, all over h. All right, so now here's my next step. So in my next step, minus 3 is going to get distributed for each term here. So I'm looking at negative 75 for that first term, minus, now I'm looking at minus 30h. Now again, just remind yourself a little bit with algebra, but it's a negative factor in front. So when you multiply in, every sign here gets switched, right? You remember all that. So now minus 3h squared, okay? And now minus 55 minus 11h minus 6, okay? And then now the negative signs are here is going to account for all the sign switch right there. So it now becomes plus 75, okay, plus 55, plus 6, okay, and all of that there over 6, I mean over h, okay? And so now lots of cancellation is going to happen. The opposite terms, the like terms with opposites, okay, minus 75 and 75. Those two get cancelled. Minus 55 plus 55, those two get cancelled. Minus 6 and positive 6, those two get cancelled as well. And look how nice it is. In the next step here, it's going to be tremendously shorter. And that's what the whole point of simplifying it down is for. So in my next step, this is what becomes. This is what's giving for us right here. Now I decide to always write the highest degree term in front. So now what about, so how about we have minus 3h squared, okay? And my next two terms, these are like terms. So I now can combine the like terms. So now those two become minus 41h, okay? And that's pretty much all there is. Now over h. Isn't that a surprise? Okay, we started out with a lot of things, and it looked almost hopeless for any of us. But look at how much simplification has done for us. Okay, so now we brought it down to, and after combining like terms and all that, we came down to this. And so I don't need to even jump back to my other board yet. Okay, and of course this h here is for the previous step. So hopefully, and because my writing is starting to get a little too tight here, but so now at least in the numerator, to simplify in a further step, my numerator here has at least the common factor h right here in both of my terms there. So now I'm going to factor out, and so my numerator here becomes minus 3h minus 4 and all over h. Okay, and so now, and that's an equal sign. Okay, and so now the common factor that appears in both numerator and denominator of our current expression here can be canceled. All right, so now look at what we have for the next step. Now we reduce it down to minus 3h minus 4. All right, minus 3h minus 4. Okay, and so now that's our simplified version, simplified answer of the difference quotient. So we've gone a long way. Let me quickly recall what we have done here. We started out having our function given as minus 3x squared minus 11x minus 6. And we are given this value. So this value was given with us right here, was given for us. So the question asked us, the example asked us to set it up and later on simplify it. And that's what we did. And so this is the starting point for the setup. And then we gradually went through the process here. So this was the ending point of the setting up right here. This is successfully the f of 5 plus h minus f of 5 over h right here. And here was the beginning of our simplification work. And we landed all the way here where we could no longer simplify any further. Okay? All right, so that's how we do part B of our example. All right, so now let's call that, I am going to spend some time erasing the board, and let's call that another FYT, an opportunity for anyone to work independently on your own, right here. All right, and your function here, f of x equals okay, so at x equals 4. So now let me quickly turn on that board right there so everyone can see your FYT problem. So go ahead and pause the video. I'm going to quickly step away and I'll be right back with your answer. All right, so now I hope you have your own answer. So the setting up for this problem would be f of and only the starting of the setting up. And of course, you have to continue with your actual setup right here. It's just a general starting indication right here. So f of 4 plus h minus f of 4, okay, and over h. So that's the starting indication point right here. And now you go ahead and supposedly you already had your setting up successfully done. So after some steps, everyone can take your own different steps. Your final answer here should be h plus 6. Okay. And so feel free to contact me for clarification of any of the steps that you have taken among between these two equal signs here. Okay. All right, so now I'm going to erase our current example 1 right here, and that's the end of example 1. Let's look at example 2, where I'm going to put that into a slightly harder kind of problem right here. All right, so let's call that example 2. Okay, and I'm going to start out with a given function. So we're going to have our function f of x here be given to be about x squared plus 3x plus 2. Okay, and so part A of the example, I'm going to say about evaluate, or some instructor may call that set up the difference quotient. All right, set up the difference quotient of this function f of x at x equals 3. Okay, so the work is just like example 1 again. So now the setting up point for us here, the question wants us to, and I should have added in, how about let me correct my instruction of the example here. And simplify the difference quotient. F of x at our given value x equals 3. Okay, so now that is the proper instruction of our part A of this example. So it is really just example 1 that we have done. So one more opportunity for anyone to have a good look of how we can do this kind of work right here. So as far as the beginning point of setting it up, we need f of and our given value a here is 3, so x equals 3 for x equals a. So now f of 3 plus h minus f of 3 over h. That's always our beginning point. And we call this setup right here the difference quotient. And from that setup, we are going to go further into setting it up further with our function properly substituted in. Okay, and with the value here. And so here we go. So now my function here is going to be, so f of 3 plus h, the function reads input square for x squared plus 3 times inputs, or 3x plus 2. So now I'm going to substitute 3 plus h for every single input x right here. So that means we have 3 plus h substituted for x. That's why I'm having 3 plus h in parentheses squared. Okay, plus 3 times h, 3 times 3 plus h. Okay, and minus, and actually plus, that here in my brackets is going to be my f of 3 plus h. And now I'm going to subtract. I'm going to erase a part of the other board to make some space for myself, because it might blend into the other board as well. So now minus, here's my f at 3. So f at 3 here is going to be 3 squared plus 3 times 3 plus 2. Okay, and all of that divided by h. So that's our next step after the beginning setting up for here. And this is our complete setup for the difference quotient of our current function here at x equals 3. But now we're going to need to proceed further as requested, as required by the instruction of the problem. Let's go ahead and simplify. Okay, so before we simplify, we need to expand and do all the algebra work to make it all completely expanded. That involves the foiling out and all that, and then we're gonna find a way to simplify. Okay, so all right, so now back on my other board, which I already cleaned it out. Then f of 3 plus h can further be FOILed. And I have already discussed about this. Think of 3 plus h all squared as 3 plus h times 3 plus h. That's what this is. And so allow me not to show how to FOIL, because there are tons of web resources out there showing people how to FOIL. So I'm going to take the next step I'm doing here is going to be after FOILing. So after FOILing, the 3 plus h all squared becomes 9 plus 6h plus h squared. Okay, and then the 3 times, so I'm going to look at 9 plus 3h after distributing the factor 3 into the two terms 3 plus h, and plus 2. This is all after FOILing out and distributing. Okay, and I shouldn't be using brackets here, just parentheses. It's good enough. Okay, and so now, and the next, and so all that here is the after FOILed f of 3 plus h, and then minus, now f of 3 is going to be, and again, I'm expressing my point here is that I don't want to do mental math here. I don't have a calculator up here, but no worry, that's not the big thing here to be done here, because algebra can help you cancel a lot of these out. So I'm going to save that for I'm going to save my mental math for other useful work. So here's 9 plus 2, okay, and then all over h. All right, so now we are ready for the next step. And so what I have now is, so I'm going to rewrite all that there, 9 plus 6h plus h squared plus 9 plus 3h plus 2, and then removing that pair of parentheses. Make sure to let that minus sign here account for all the sign change right there. So minus 9, minus 9, minus 2. So now lots of cancellation, and that's why I didn't want to spend my time doing mental math here. 9 cancel with this opposite 9. This 9 here cancel with that other opposite 9. Okay, and this 2 cancel with that other opposite 2. And now we have 6h and 3h. They are like terms. So now look at how short our expression becomes. And I forgot to put the h in the denominator there, but it is here now. So now our next expression becomes looks as following: h squared plus 9h over h. And now we are so ready for simplifying it further. So factoring out, I'm going to go ahead and factor out a common factor h right here. So that makes it h in parentheses h plus 9 all over h. Okay, and so now we cancel the h's away, that as a common factor. And so now my final expression here is h plus 9. Okay, so we came to the very simplified point of our difference quotient of our current function at x equals 3. Okay, at that function. And so now here's what we do for part B of the example. All right, so now we already had the setup. The function is still the same here at that given value. So now once we simplified, here's the next step. And this time I really mean to evaluate. So now evaluate the difference quotient of f of x at x equals 3. So now difference quotient of f of x at x equals 3 is now more like just a name, and we have already found it. But this is what I'm saying. For h equals 1, and then do another problem, h equals 0.1, and then do another problem, h equals 0.01, for example. And I can put more the h values, but I suppose 3 of those are good enough for us. Okay, but what's the intention of this part B here in this current example? The idea now is that I am going to, now let me roll back to the other board. This was our final simplified difference quotient of f of x at x equals 3. So we already found that. So there's no need to repeat the whole process here. That was for part A. We came to that. So now the idea of part B now is that we are going to take this and look at and see how we still have the h variable remains right here. So our difference quotient at the end right here. Now example 1, some problems in example 1 we came down to a completely just numerical answer. But some other problems in example 1, as you have already seen, we came down to the simplified point, the simplified answer where we still have some h variable that's left over. And the same thing here. Our, even though very simplified answer for the difference quotient, but we still have the h variable being involved here, being left over here in this final expression. And that's the whole idea right there. So with our very final simplified expression, simplified answer for the difference quotient of f of x at x equals 3. But now with the h variable being left over, we want to really evaluate, come up with the actual numerical value further at these 3 different given h value. All right, so this is what we do right here. So now, how about for h equals 1? Okay, it's never hurt to write it down for every single detail. For h equals 1, let's see what happens. So our simplified difference quotient now so h plus 9. So that means now for h equals 1, h plus 9 now becomes 1 plus 9. And that 10. So we had an answer. That's all it is. That's all the problem was looking for. Okay, so now we can start picking up pace. Okay, so now I'm going to erase that line because I need more space. Or actually I can just go to my other board, because I have left this here long enough. All right, so now for h equals 0.01. So this is what, so with our h plus 9 was our simplified difference quotient, but now for h equals 0.1, it's going to become, it's a little bit informal writing things this way, but it works for now. So 0.1 plus 9. So our answer came out numerically as 9.1. Okay, and so now you can work ahead of me. But yes, you will see where I'm going for the next value of h, because now our difference quotient, before plugging in these values for h, then our difference quotient entirely remains in terms of h. Okay, and so now with h being given at a different value, then here h plus 9 as our final simplified difference quotient, it's going to be 0.01 plus 9, and that gives us a very numerical answer, 9.01. Okay, and really that's all the intention here, and I, after 2 examples with part A, B, and C's, I hope I have given enough the problems and examples so that my whole intention again is that the viewers for this, is after seeing these examples, you are going to have some further opportunity to work and strengthen your skills to work on difference quotient and how we apply this. It will wait for the next video when we actually take this concept of difference quotient and apply that into our work for calculus. So here, the entire lecture here is surprisingly nothing calculus at all. It's completely algebra, but I aimed at strengthen your skill, your ability in working with difference quotient. Okay.